There guys, Mr. Carlson here, and in this video I want to go through an example problem of how do we find the centripetal acceleration of an object. In the previous few videos there that I posted, they go through and they define what centripetal, whoops, that's not what I wanted to do. Hang on, gotta get my pen here. There we go. They define for us what the centripetal acceleration of an object is, which is basically the acceleration towards the center of the circle of something that's moving in a circle. And they also derive an equation for centripetal acceleration. So if you haven't watched those videos yet, make sure you go right now and go watch those videos, and then you can come back to this one. But the equation that we get for the centripetal acceleration looks like this. AC is equal to v squared over r. So the velocity squared divided by the radius of the circle gives us the centripetal acceleration of an object. So in this problem right here, we've got this 0.013 kilogram rubber stopper, and it's attached to a 0.93 meter length of string. The stopper is swung in a horizontal circle, making one revolution in 1.18 seconds. Find the centripetal acceleration of the stopper. So if I were to draw a picture of what's happening right here, here's our rubber stopper. It's attached to this string, and it's being swung around in a horizontal circle. We'll say it's moving this way. This would be, since it's a horizontal circle, this would be like a top view of it, or what's called a bird's eye view of this. So it's like if we were standing on or if we were up on the ceiling looking down on this. So like a side view would be like maybe somebody is standing here and they're like holding onto this string like this, and they're swinging it around. Give him another arm here. He's swinging it around like this, basically. So this would be like the side view of what's happening. This is the top view looking down on this. So we're going to refer to this top view here. So we got this swinging around in a circle. The only things they tell us are the length of this, which is 0.93 meters, and they give us the mass of the rubber stopper, which is 0.013 kilograms, and they also tell us the time that it takes to make one complete rotation. So they give us the time, which is 1.18 seconds. So the only thing we have to figure out, the question is asking, what's the centripetal acceleration? If we come over here and look at our equation here, I can figure out the centripetal acceleration by taking the velocity of the object squared and divide it by the radius of the circle. Well, I know the radius of the circle because I know the length of the string, 0.93, so I know this part of it. But the question does not give me the velocity. I don't know how fast it's moving around here, at least not right off the bat. And so I'm actually going to have to take a step back and try and figure out, well, what is the speed or the velocity of the stopper as it's moving around this? Do I have enough information to figure out the velocity and then use my equation for centripetal acceleration? And the answer is yes, I do, because they tell me that it takes 1.18 seconds for this rubber stopper to do one complete rotation around this circle. So if we go back to, we'll do speed is equal to distance over time. Distance over time. Well, I can figure this out because I know how long it takes. And how can I figure out the distance, though, is the real question. How can I figure out the distance that this object travels? Well, this would be the distance around the circle is called the circumference. The circumference of the circle would be the distance around this. And so actually the only thing I have to do is I just have to plug in the circumference for the distance and then divide it by the time. So the circumference of a circle is equal to 2 pi times the radius, 2 pi r. So I'm just going to take 2 pi r and I'm going to plug that in for my distance, 2 pi r, and I'm going to divide it by the time, and that will give me the speed or the velocity of this rubber stopper as it moves around. Because if you think about it, so the centripetal acceleration just has to do with the acceleration towards the center of this circle. In other words, it has to do with the acceleration based on how it's changing direction. But the velocity, in regards to just how fast it's going, in regards to its speed, so if I were to look at the velocity of the object, like once the rubber stopper gets like here in its pathway, and I were to look at the velocity here or right here, now it's accelerating based on its change in direction because it's constantly changing direction the entire time. But the speed of it is not. The velocity here and here is actually the same as it's moving around. So I can plug in some numbers here because I know the radius of this, and these two things are just numbers, and I know the time, and so I can plug those in and figure out what is the velocity of the rubber stopper as it's moving around here. So let's plug in some numbers here. So 2 times 3.14 times the radius, which is 0.93, divided by the time that it takes to do one complete revolution, which is 1.18 seconds. And let's see, crunch the numbers on that, and we should get 5 meters per second. All right, so that's the velocity. That's the velocity that this has as it's moving around this circle. But the centripetal acceleration now we can solve for. Let's see, centripetal acceleration is equal to velocity squared, which is 5 meters per second. So 5.0 squared divided by the radius, 0.93 meters. Crunch the numbers on this, and we should get 27 meters per second squared. So that's the centripetal acceleration of that rubber stopper. So one thing you might want to write down if you have not already done so. So you should have this equation written down somewhere in your notes. But another thing we would want to probably write down is what we did right here. So in a lot of these problems, they may not tell you explicitly what the velocity is. You may have to figure out what the velocity is. And so for that equation there, an equation that you can kind of add to your toolbox here would be, I'll write it down here, velocity is equal to, we're basically just changing this part of it, the distance or the change in position, which is 2 pi r over t. So I would probably write this equation down, that this is the velocity for anything moving in a circle, basically. So velocity for circular motion. So I would write that equation down there as well.